Hello again, our most valued student. My name is Confident and welcome to Egurlen Text 24-minute lesson. This is a continuation of factorizing by grouping, and the last lesson that we did, we were looking at the difference of two squares. We did look at factorizing by grouping. We are going to look at typical exam questions as a reminder, but for now we are going to focus on the difference of two squares. Please refer to the previous lesson in order to understand this module or this particular 24-minute lesson on the difference of two squares. As a reminder on the difference of two squares, we said if you are given a problem like this one, x squared minus y squared, the thing is, pretend you don't see these squares, but that's the name we're taking it from the difference of two squares. If you pretend you don't see these squares, what you are looking at, you are seeing x minus y. So this is the first thing that you are going to write. What you are seeing, it's x minus y. Then you open another bracket, then you're going to have x now with an opposite sign, which is x plus y. Then you would have factorized a difference of two squares. Again, the next problem is 8 squared minus 64. If you are not clear, you might not see that this is the difference of two squares, but if you look carefully, you can see that this is a difference of two squares. How is it? If you look at 64, you know that 64 is 8 squared. So if you say x squared minus 8 squared, you can see now this is a difference of two squares. Again, if you pretend that you don't see the squares, what you're going to have is x minus 8, and the other one is going to be x plus 8. This is the solution of x squared minus 64 when you're solving it through a difference of two squares. That is what they mean by factorizing. Now, the next problem that we're going to have is this kind of problem. 50a squared minus b squared. Now, again, as I said, this kind of a difference of two squares seems a bit hidden, but you need to be careful. The moment you can see a squared, b squared, and a negative, you must suspect this might be a difference of two squares. But there is a step further that you must go through so that you can see it clearly that is a difference of two squares. The first one is, let's factorize by grouping. What is common, or the highest common factor of 8 and 50? We said between the two numbers it's a 2. If you take out a 2 from 50, you are going to have 25a squared minus 8 divided by 2 is 4b squared. Now you can continue to say this is 2. Now what is 25? 25 is 5 squared, a squared. And what about 4? 4 is 2 squared, b squared. Now, using the concept of the difference of two squares, you can actually rewrite this as, it can become like this: 2, 5a, put brackets, squared, minus 2b squared. It is also allowed, squared. You can actually do that, and then you close that other bracket. But still, you can continue with the current method, whereby, as I said, pretend you don't see these squares. Remember, everything must have a square so that you can write it as a difference of two squares. If you pretend you don't see those squares, what you're going to have is you're going to have a 2. Now, because there are going to be other brackets, you can start with a square bracket. Now, what are you seeing? You are seeing 5a, you write it, 5a minus 2b. This is what you see when you remove those squares. But again, remember, in a difference of two squares, you rewrite the same thing in brackets, but now with a positive sign. It's 5a plus 2b. Then you close the pickup bracket. This is what we mean by factorizing a difference of two squares of this nature. Sometimes they can give you a problem, as I said, whereby you need to factorize first by grouping and then only to discover that it was a difference of two squares. Let us look at another type again that they can bring, which is a hidden form of a difference of two squares, but it is also a difference of two squares. Let me write it in big. It is x plus 1 squared minus 9. Now you can say let x plus 1 be equal to m. So now it means x plus 1 now is going to be substituted by m. So inside here, where you see x plus 1, we can continue to say this is equal to m squared, remember, minus 9. Why m squared? M is now replaced by x plus 1. Remember, we said let. By saying let, it means now wherever there is x plus 1, we just substitute it and put an m. Now this can continue and become m squared minus, again, to make it a difference of two squares, we say minus 3 squared. Now, again, it's now simpler, where you're going to write it as m minus 3 and m plus 3. But this is not the answer, remember, because the question never gave you an m, but the question gave you an x plus 1. This was a simpler way of trying to avoid confusion of the x plus 1. But when you have done it now, you replace back m as x plus 1. So where there is m now, you put the original version, x plus 1 minus 3. Remember, that's where your m was. And then you have got x plus 1 plus 3. So you can see x plus 1 is the one that was representing m there. So now you've got now x plus 1 minus 3. Numbers together, 1 minus 3 is minus 2. So you'll have x minus 2. Again, x plus 1 plus 3, you'll have x plus 4. Then this is the final solution of the above problem of the difference of two squares in a hidden way. However, some might not like substituting, whereby you can directly do it like this. Let me write it again, x plus 1 squared minus 9. You can say this is equal to x plus 1 squared minus 3 squared. You can see already, you can change 9 into 3 squared. Now, as I said, pretend you do not see these squares. So you just write what you see. So what are you seeing? In the first one, you're going to see x plus 1 minus 3. You're writing it as a whole, x plus 1 minus 3. And write the other one, x plus 1 plus 3. Remember, the other one is the negative, the other one is the positive, and it will give you the same answer as x. 1 minus 3 is minus 2 with your calculator, and x 1 plus 3, it's a 4 with your calculator. Now let us look at the other versions of a difference of two squares. You can see here they gave 50x cubed minus 2x. So what is a difference of two squares also that is hidden? If you take out, let me write it again, it looks as, if I can write it somewhere plain, if we can look at it again, 50x cubed minus 2x. From a first glance, you will think like, well, this is a different problem, it's not a difference of two squares. But if you look carefully, you will see that this is actually a difference of two squares. For example, looking at the numbers, you can see that between 50 and 2, 2 is common, so we can take 2 out, fine. But also between x cubed and x is common. Remember, you take the number with the lowest power. So here we are going to take x. Now, if we divide 50x cubed over 2x, 2 into 50 is 25. So we will have 25. X into x cubed, we will have a square. So you're going to have x squared minus, you take another one again, 2x over 2x. You can see 2 into 2 it's a 1, and x into x it's a 1. So you will have 25x squared minus 1. Now again, it still look a bit hidden, but this is a difference of two squares. Let's continue. You will have 2x. You know 25 is 5 squared, x squared. Now what about 1? Again, we mentioned previously, 1 is the simpler one, because even if you say 1 squared, you still get a 1. 1 squared is equal to a 1. Hence, you can just say minus 1 squared. So if you can do that, you can see now you have got inside the bracket square, square, square. So when you have got these squares inside the bracket and there is a negative sign, it means it is now a difference of two squares. Then you can continue to say 2x. Pretend you don't see the square. The square is there. You are going to write 5x minus 1, and the other one is 5x plus 1. Then this is the final solution of that particular problem. Another problem that they can bring, let's look at this particular problem. It says 3m n squared minus 16 plus 7, 16 minus n squared. I'm going to write it again in a fresh board, and then we're going to try to solve it. But whenever you're referring to, this has got notes that are written. You can come and really look at it carefully, pause the slide, and you'll understand it much better. Let us look at this problem. It says 3m n squared minus 16 plus 7, 16 minus n squared. Now, again, there are two versions in here. There is factorizing by grouping that you're going to look at, and somehow, if you're remembering well, this can be a difference of two squares. You can see n squared minus 16, and 16, you know it is 4 squared. So you will have n squared minus 4 squared, which is a difference of two squares. But the problem is we still have 16 minus n squared. But how can we make this altogether less complicated? Now, let us look at what is first inside the bracket and try to make it look the same. If you still remember, we said 16 minus n squared. You want to make it to become n squared minus 16. You always take out a negative 1. When you take out a negative 1 or a negative sign, you are going to have minus 16 plus n squared. You just interchange the signs. So it's going to be minus 16, if I can write it in small writing. It is going to be minus 16. Remember, we took out minus 1. You will have minus 16 plus n squared. Now, when you have got this, you can rearrange it to say minus 1. You will have n squared minus 16, which is similar to the first bracket. So if you can write it like this, you will have 3m n squared minus 16. I'm going to take out a negative 1, so it's plus 7 with a bracket minus 1. Then you're going to have, as we did previously, n squared minus 16. Just refer to this so that you will remind yourself what I just did. Now this continues as 3m n squared minus 16. Now 7 times minus 1 is minus 7 n squared minus 16. Now you have made the two brackets look alike. Now you can factorize n squared minus 16, n squared minus 16. That is the grouping now method. So n squared minus 16 is common. If you factorize it out, you are going to have what will remain. You are going to have 3m remaining here, minus what is remaining in the other one is minus 7. So you are going to have n squared minus 16, 3m minus 7. But this does not end there, because n squared minus 16, you can see it can still go further. It is going to be n squared minus 4 squared. Why 4 squared? Because 4 squared is 16, and 3m minus 7. This is equal to Remember, difference of two squares, n minus 4, n plus 4, and 3m minus 3m minus 7. Then this becomes the solution to this kind of problem. Now let us look at the typical exam questions that you usually find whereby it is the factorizing by grouping, and it's usually in question number 1. The first problem that we have here is factorize 10x squared y squared plus 1 minus 23x y plus 1 plus 12 y squared plus 1. And by observation already you can see y squared plus 1 repeating, y squared plus 1 and y squared plus 1, which means in each and every one of them y squared plus 1 is common. Now because there are two involved, there is a plus sign. Usually you must put a bracket so that your maths will be correct. Then you open another bracket. What will remain when you take out y squared plus 1? Here you will remain with 10x squared minus, if you take out that y squared plus 1, you will remain with 23x plus, if you take out the y squared plus 1, here you will remain with a 12. Now this is going to go further. However, we have not covered the section of factorizing the quadratic or trinomial. Hence we are going to come back to the similar problem and solve it further. This is not the end of the problem. We will again look at the final solution when we have covered that concept. Again, let us look at this one. It's a typical exam question. It says factorize x cubed minus 2x squared plus 3x minus 3x plus 6. Again, when you are factorizing, let me write it again. X cubed minus 2x squared minus 3x plus 6. Now we can look at the first two items and also look at the last two items. If you look at the first two items, what is common there? X cubed minus 2x squared. You look at the highest power. What is the highest power? I mean the lowest power, because as far as numbers are concerned, we have a 1 here, which we can ignore, and a 2. So there is nothing common with the numbers. So what is common is the x's. Now you look at the lowest power, and in this case 2 is the lowest power. Hence we can take out x squared, because 2x squared can go into x cubed, but x cubed cannot go into x squared. So if we take out x squared, this is the same as saying x cubed over x squared. What you're going to get is, how many x's do you have here? You have got 2. Here you're going to cancel the 2, 1 will remain, hence you're going to have x minus, now the negative 2x squared over x squared. You can see the x squared and x squared will cancel, you remain with minus 2. The next one, what you have to see is between 3x and 6, what is common there? You can see that 3 is common. Now if we take out 3 as common, have a look, you are going to have, if we take out 3 as common, you are going to have x, because it's 3x over 3. You are going to have an x. I'm ignoring the sign intentionally so that I want to show you something. Again, 3 into 6, you are going to have a 2. Now I want you to be careful on how I'm going to put the signs. My aim is to make sure that the second bracket matches the first bracket. So now if I took out a positive 3 here, I was going to have a minus x, a plus 2. Minus x plus 2 is not what I have on the other side, but I want to have x minus 2. In other words, I want this sign to change to become a negative. Hence, I must take out a negative sign. If I take out a negative 3 into a negative 3 will give me a positive x. A negative 3 into a positive 6 will give me a minus 2. Now have a look. You have got x minus 2 on both sides. Hence you can write the first one is x minus 2, one of the bracket, and then you have got outside the bracket x squared minus 3. Well, 3 doesn't have a square, so this becomes your final answer. Moving on again, let's look at this problem. It's a typical exam question. 3x squared and 4y minus 3 minus 3x and 3 minus 4y. And already, if you have now gotten used to the trick here is inside the bracket you have 4y minus 3, and in the other bracket you have 3 minus 4y, which means you must take out a negative, and when you take out a negative, it will rearrange and give you the other one. What am I saying? I'm saying if you take out in 3 minus 4y, if you take out a negative, you will have minus 3 plus 4y. If you rearrange it, it will be minus bracket 4y minus 3. And where is 4y minus 3? You have it again in the other bracket. Hence, you're going to have 3x squared. You're going to have 4y minus 3 and minus 3x. You take out a negative 1, remember? You will have 4y minus 3. Now, this continues to become 3x squared, and you have got 4y minus 3. Now, a negative 3x times a 1, you have got a positive 3x and 4y minus 3. This will become 3x squared plus 3x. That is outside the bracket. Inside the bracket, you have got 4y minus 3. You can go on to say there is something common between 3x squared and 3x. You can go on to say 3x is common in that one. So 3x into 3x squared, you will have x plus 1 and 4y minus 3. This will become the final answer. Lastly, let's look at the last typical exam question. You are given 5x36 minus 80y squared. They like this kind of problems. Again, this is a hidden difference of two squares. Now have a look. If we take out a 5 between the numbers, you will have x to the power 36 minus 5 divided by 80. You are going to have, if I use my calculator, you are going to have a 16y squared. Do you see that something talks to us that there is a difference of two squares there? But the trick now is the power of 36. What do we do with x to the power 36? Now look at this. We're going to look at it again in exponents, but x to the power 36 is same as x to the power 18 times 2. You understand? So you're going to have 5x to the power 18. In a way, you put another bracket, there is a 2 there. Why? Because 2 times 18 is 36. Minus, again, what is 16? 16 is 4 squared and then y squared. Why am I putting the squares? It's because remember we want to put the concept of a difference of two squares. Hence you're going to have here a 5. Then you're going to have a difference of two squares. You're going to have x to the power 18 minus 4y. Ignore the 2's. Remember, if you are to ignore the square, the square, the square, what you are seeing there is x18 minus 4y, and you are also seeing x to the power 18. Now it will be plus 4y. Then this becomes the final answer. Now, we have come to the end of our lesson on factorizing by grouping as well as a difference of two squares. See you again in the next lesson. Remember, whenever you are working on these, try to follow each and every lesson as the previous lesson builds on the previous lesson, especially if you are within the same topic. Thank you.